Hello my all dear students, welcome to mathematics classes for 9th standard. We are doing chapter number 6, that is lines and angle, and this is part number 2. If you have not seen part number 1 yet, so just go and back and just first check part number 1 of lines and angle. So today we are going to solve exercise 6.1 and then we are going to learn about parallel lines and transversal, okay? Or we can learn that angles formed by transversal, okay? So by whom? By your Jerry sir. So let's start the video.
So in our previous video we have already started our exercise 6.1 where we have completed question number 1. Today we'll start from question number 2. Now just check question number 2. In figure 6.14 lines xy and mn, xy straight line and mn intersect at point O. If angle POY, this POY is how much? This symbol is what? 90-degree angle. And A is to B, this angle and this, they are in the ratio 2:3, then find C angle. Okay, so let's solve this question. As you can see, we have drawn this one figure already in our copy. So A, B, C, it is given. We have to find out A and B, and this ratio is already given 2:3, and this MN and XY are intersecting at point O. Okay, so they will make vertical opposite angles also, and angle POY is given 90-degree angle. How much? 90-degree angle. If angle POY is 90-degree angle, therefore this angle will be also how much? Angle A plus B equals to how much? 90-degree angle only. Okay, clear or not? This will be also how much? Because it's straight line, no? So this will be also how much? This plus this, 90-degree angle only. Now see, angle A plus B, this A plus B equals to how much? Angle POX. They are making, if we add A plus B, so it will make angle POX. And angle POX is equals to what? Angle POY. And POY equals to what? 90-degree. It is already given in the question. So sum of the ratio, because ratio is given 2:3 of AB, so 2 plus 3, 5. So we can find A value. How? As A's ratio is what? 2. So 2 is 2 upon 5 multiply by 90. So it will become how much? 5 into 18, 90, 18 to the 36 degree. So how much it comes? 36 degree. In the same way we can find out B also, because B ratio is 3. So 3 upon 5 into 90. Again 5 into 18, and 18 3 is a 54 degree. So how much comes? 54 plus 36. If you add, it will come 90 only. 54 plus 6, 60, 60 plus 30, 90 only. So it comes 54 degree and 36 degree. A and B value. But we have to find out the value of C. Remember this one. Now if we check properly, so we found that MN is a line. This one, MN, this one line in the original figure. This MN is a line, and this OX is working as a what? Ray only. So see, we have drawn this much only, this much part, MN and OX. Now this OX is working as a ray on this one. So we can say that MOX plus NOX, it will make how much? Linear pair only, 180 degree. Now MOX is what? B, and NOX is what? C. So B plus C equals to 180. So in this way C equals to 180 minus B, and what is B value? Just we have find out 54. So 180 minus 54, it comes how much? 126 degrees. So in this way we have find out C value also, B value and A value also. So I hope it is clear to you. So now question number 3 and 4 you will try by yourself. So I am regarding as homework. Okay, this one also and this one also. Now we will move to question number 5. In the figure 6.17, POQ is a line, POQ, this one is a line, and ray OR is a perpendicular on this one. Perpendicular, it means 90-degree angle it will make here also and this side also. Okay, OS is another ray, this is another ray between rays OP and OR. Prove that ROS is half of angle QOS minus angle POS. This one question number 5 we are doing here. Let's solve it. So as you can see here, we have drawn only the figure which is given in the book here in the copy. So POQ is a line which is already given. POQ is a line which is already given, and OR, this OR is perpendicular on this POQ. So this angle is how much? 90-degree angle. Now if this angle is how much? 90-degree angle ROQ, or you can say QOR, therefore POR will be also how much? It will be also how much? 90-degree only. They both will be 90-degree as OR is perpendicular to PQ. Now what we have to prove? That we have to prove ROS is half of QOS minus angle POS. Now we can write this one in this way also, because 1 multiply by this, so angle QOS minus POS upon 2 only it will come. Now let's start the proof of this question. So angle POR is given 90-degree angle. Okay, POR 90 degree because we have QR is given 90 degree. So angle POS plus ROS equals to 90 degree. Why angle POS plus ROS? Because angle POR is made up of two angles, POS plus angle ROS. When we add these two angles, so it becomes POR only. So angle POS plus ROS equals to 90 degree angle. Now we will keep ROS here only and we'll take this POS to that side. Why we are doing this? Because we have to find ROS only, which we have to prove. Okay, so ROS we have kept here only and we have taken POS to the right hand side. So it comes in minus, as it was in plus here, so it becomes minus. 90 degree minus angle POS, it becomes equation first. Now QOR, right hand side, QOR is also given how much? 90 degree angle. How we can write QOR in another way so that we can include ROS? Just check. If we subtract ROS from QOS, so what we will get? QOR only. Just check again what I am saying. If we subtract this much part from this whole, okay, again pay attention, from QOS, from this full, if we subtract this much part, this is what I am shading here only, ROS. If we subtract this ROS from this whole, so what will left? QOR only, or you can say ROQ, same thing only. So we can write QOR as angle QOS minus angle ROS equals to 90 degree, already given, as OR is perpendicular to PQ. So QOS minus, now what we are doing? We are doing transposition method. We are taking this 90 degree to this side and angle ROS to this side, because we need ROS separately. So minus ROS was there, so we have taken this side, so it becomes plus ROS. 90 degree was plus, so it becomes minus. So we got equation angle ROS equals to QOS minus 90 degree. So we can write in this way, angle ROS equals to QOS minus 90 degree angle. It is same thing only. So it is equation second. Now what we are doing? We are adding equation 1 and equation 2 both. Just check here. So ROS here also. So ROS, angle ROS, we are adding 2 times, equals to now 90 degree minus angle POS. So 90 degree minus angle POS in equation second, plus, because we are adding, angle QOS minus 90 degree, angle QOS minus 90 degree. When we open the bracket, so 90 degree minus angle POS plus QOS, angle QOS minus 90 degree angle. ROS plus ROS, it becomes 2 angle ROS. Now just check here, it is 90 already, okay, plus 90 and it is minus 90. So from 90 we can cut this 90 minus 90 cut. What left? Angle minus angle POS plus angle QS. So we can write in this way also, plus angle QS minus angle POS. Sign will remain there only, same as it was earlier. So it becomes 2i's of angle ROS equals to angle QOS minus angle POS. Now we are taking this 2 to right hand side. So right now it is in multiplication form with ROS. So come in downside. So angle QOS minus angle POS upon 2. As I told you starting that we can write this form in this way also. So it comes in this form. So we can convert in this form only. So angle ROS, we can take 1 as common, 1, and this we can bring this 2 downside. So 1 upon 2 angle QOS minus angle POS only. So either you can write this one also, this is also correct, and this is also correct. So we have proved that angle ROS is half of angle QOS minus angle POS. So I hope it is clear to you. Now move to question number 6. So now in question number 6, they have not given the figure. Okay, this is the figure of question number 5. So just we are doing question number 6, so we have to make the figure by ourselves by reading the question. It is given that angle XYZ equals to how much? 64 degrees. So we have to make an angle in which angle XYZ is how much? 64 degree, and XY is produced to point P. So first what we have done, we have drawn angle XYZ is equals to how much? 64 degree. And then what they are saying? They are saying that produce XY more, produce this XY more till point P. Okay, so let's produce this one. So as you can see, we have produced XY till point P. Now what they are saying? They are saying that draw a figure from the given information as we have drawn already. If ray YQ bisects angle ZYP, if ray YQ, now see YQ. So now we have to draw a ray YQ here, so that in this way that it bisect angle ZYP. So we can draw in this way. Okay, this ray is what? Q. So it is YQ ray which is bisecting. It means this angle is equal to this angle. Okay, we can put it double. So whatever this angle, so same angle is this one also. We can assume this is A and this is also A. Okay, both will be same as YQ is bisecting, okay, in equal parts. Bisect means dividing in equal parts. So at last, after drawing the figure, they're saying that find angle XYQ. Where is XYQ? Just check here. XYQ, it means this full figure, A plus 64, and reflex angle QYP. Reflex angle QYP. QYP, where is QYP? QYP, it means after taking this one, how much it is, whatever it comes from the whole, this 360, we will subtract this one, so we will get what? Reflex angle QYP. This is called only reflex now, except this, all this full, that is called reflex angle QYP. So let's solve this question. So on line XYP, you can see this is a line. Here angle XYZ plus this one angle, this angle XYZ 64 plus angle PYZ plus this whole angle from here to here. These two angles making what? 180 degree angle, that is called linear pair. Okay. Now if we are adding them, so what we will get? XYZ is already given 64, and PYZ we can divide it in two parts, that is A plus A, or you can say PYQ plus QYZ. We have written this one. Now this value A, both are same because QY bisecting this. So we can write 64 plus A equals to 180 degree. 64 plus 2A equals to 180. 180 will remain here. 64 will go left, right hand side, so it becomes minus because it was plus here. So 180 minus 64, it becomes 116. 2A equals to 116. So A will remain here. Now 2 is having which relation with A? In multiplication relation. So it will go in downside. So 116 divided by 2, it comes A how much? 58 degree. A comes how much? 58. So if this much is 58 degree, this is also how much? 58 degree. Okay, 58 and 64 at last. Now what we have to find out? XYQ. So 64 is this much, and this was how much? 58 plus 64. We can find out our XYQ. So let's find out. XYQ equals to XYZ plus QYZ. 64 plus 58, it comes how much? 122 degrees. So first we have find out. Now we have to find reflex angle QYP. Reflex angle QYP, it means except this we have to find this full angle, this from here to here. Okay, this one. So what we can do, from whole is what? 360. If from 360 we can subtract this much angle, this is angle what? Angle PYQ. So we can find our reflex angle easily. So what is the whole angle? 360 minus angle QYP, that is how much? 58. So let's find out. 360 minus angle QYP, that is 360 minus 58, it comes how much? 302 degrees. So in this way we have found out our reflex angle QYP also. And here we have completed our exercise 6.1. So I hope it is clear to you. If you have any doubt, so you can ask me in comment section. Okay.
So now we will talk about the angles made by transversals. As you can see here, these two lines M and N. As you can see this one, these lines M and N. These two lines are there, which is cut by a transversal L. This L is a transversal. So L is intersecting these two lines. Okay, you can say intersect these two lines at two distinct points. At two distinct points, which are distinct point? At P and at Q. At these two distinct points, this transversal L intersecting these two lines M and N. Okay, this is a transversal. So transversal is a line that intersect two or more lines at a distinct points, at distinct point as P and Q. That is called transversal. Now we'll talk about the angles which are made by transversal on these lines. As you can see here, exterior angles. Exterior means which is outside. So the angles which are outside here are 1, 2, 8 and 7. This one, look at this one, green one, 1, 2, 7 and 8. These are what? Exterior angle, because these are made on the exterior side of the lines, outside the line, not interior. Okay, outside. That's why it's called exterior angle. So angle 1, 2, 7, 8, these all are what? Exterior angles. Now we are talking about interior angles. So interior angles means angles which are made inside the lines. As you can see here, angle 4, angle 3, angle 5 and angle 6. These are what? Interior angles, which are, because these are formed inside the lines. Okay, now we'll talk about what pair of corresponding angles. What pair of corresponding angles made by transversal. So when the transversal intersect these two lines M and N, so corresponding angles made. So corresponding angles, which are corresponding angles, just check here. As you can see here, 1 and 5. Which one? 1 and 5. Why 1 and 5 are corresponding angles here? Because see, 1 and 5, these two angles are those angles which are made on the same side of the transversal. As you can see here, this L is a transversal and these are made on the left side. Made on the left side. Which one? 1 and 5. If you look at the 1 and 5, so these both angles made on the left side of the transversal, and out of which one is what? Exterior. See, angle 1 is exterior and angle 5 is interior. So if angles which are made by a transversal on the same side, out of which one is exterior and another is what? Interior, then those angles are called corresponding angles. Okay, so angle 1 and 5 are corresponding angles. In the same way, what? Angle 2 and angle 6, these are also what? Corresponding angles also, because these are made on the right hand side. See this one, 2 and 6, which are green color, 2 and 6, these are also pair of corresponding angles, because these are also made on the same side of transversal, and one is exterior, one is interior. And more are there, these are 3 and 7. See here, this 3 and this 7, these are also made on the same side of transversal. This 3 is interior and 7 is exterior. So this is also a pair of corresponding angles. More are there, let's check here. 4, this one 4 and this 8. So this 4 and 8 also are what? Pair of corresponding angles. So I hope it is clear to you what is corresponding angles. Okay, now we're talking about what? Pair of alternate exterior angles. Alternate exterior angles. So first is what? 1 and 7. This 1 and this 7. Let's look at here, 1 and 7. Now as we are saying, pair of alternate but exterior. Alternate means, see, 1 is there and 7 is there. They are made on the different side of the transversal. 1 is on the left side of the transversal and angle 7 is on the right side of the transversal. Just check here, properly observe it. Okay, now why they are calling exterior? Because they are already outside the lines. See, that's why they are called exterior angles. 1, 2, 7, 8, these all are exterior angles only, and out of which are the pair of alternate exterior angles? 1 and 7. The same way 2 and 8. Which one? 2 and 8. This one, 2 and 8. This is also what? Exterior angles, pair of exterior angles. I hope it is clear to you. A pair of alternate exterior angles. Now we're talking about what? Consecutive interior angles on the same side of transversal. As you can see, this color one, P and this one, P and Q, which is made on the left side of the transversal L. Okay, so angle 4 and angle 5 are what? Consecutive interior angles. Just look at here, this 4 purple and this 5 also. They are made on the same side of the transversal and both are interior. The main thing is that both are interior. That's why they are called what? Consecutive interior angles, which are come after 1. Each after come after 1. After 4, this one, see just which talk about the line, the left side 1, 4, 5, 8. So 4 and 5 just come after each other. No, these are what? Consecutive interior angles. In the same way, 3 and 6 also what? This 3 and this 6 is also what? Consecutive interior angles on the same side of the transversal. So I hope it is clear to you what is corresponding angles, what is exterior alternate angles, what is consecutive interior angles. I hope it is clear. Now see, pair of alternate interior angles. Just we have learned about pair of alternate exterior angles where the angles are outside. Now talking about the angles which are inside the lines. So pair of alternate interior angles, like we can see here, just pay attention, don't be confused. 4 and 6. See, these both angles are coming inside the two lines M and N, and these are interior angles, but one is left hand side, another is right hand side of the transversal L. That's why they are called alternate. That's why they are called alternate, and these both are interior. That's why they are called alternate interior angles. The same way 3 and 5 also what? Alternate interior angles. 3 and 5. This is also what? Alternate interior angle. So I hope it is clear to you what is pair of alternate interior angles. Next, axiom. Now comes what? Axioms. As we have learned all the angles which are made on the transversal. So let's learn about axiom first. Actually, this is axiom 3 because 1 and 2 axioms we have learned in our previous video. Let's learn about this next axiom. What it says that if a transversal intersect two parallel lines, as you can see here, two parallel lines are there, M and n. These are what? Parallel lines. What is parallel lines? Parallel lines are those lines which are never intersect each other. Okay, it will goes on and on, and we have talked about this one in our previous video already. So m and n, what you can say that parallel lines, and this L is what here? This L is a transversal. So if a transversal L intersect two parallel lines M and N, then each pair of corresponding angles. Now already we have talked about corresponding angles. So what is corresponding angles here? Let's check here. We can say 1 and 5. Okay, one is, they are on the same side, but one is what? Exterior, that 5 is what? Interior. So they are what? Pair of corresponding angles. What they are saying, they will be equal. What they are saying, they will be equal according to axiom 1. Okay, in the same way we can say this 2 and this 6 also what? Will be equal, because they are corresponding angles, so they will be equal. But when, remember, here we are talking about parallel lines. M and N are parallel lines. In previous examples which we have learned, M and N were not parallel line, but here these are parallel. So there they were corresponding but not equal. But when parallel lines are there and they cut by transversal, so corresponding angles will be equal. In which case, when there will be parallel lines cut by transversal. Remember this one, okay? Now just check here, pair of corresponding angles. Here as you can see, yellow one, 4 and 8 are also equal, okay? And even angle 3 and angle 7 are also equal. This one, just check here, angle 3 and angle 7, these are also corresponding. 4 and 8, these are also what? Corresponding angles only. So 4 and 8 are equal, 3 and 7 are equal. In the same way we have learned 1, this 1 and 8, this 5 is equal, and 2 and 6 are equal, because they are pair of corresponding angles. Okay, so they will be equal. Remember when there will be a parallel lines cut by a transversal. Okay, clear? Now axiom 2. Axiom 2, just you can say that it is a, you can say, reverse of, or you can say converse. It is a converse theorem of, converse axiom of first axiom. Just we have learned, as it says that if a transversal intersect two lines, so transversal there L intersecting two lines M and N in such a way that the pair of corresponding angles are equal. Now already they have given that the pairs of corresponding angles are equal. It means 1 is equals to 5, 2 is equal to 6, 4 is equal to 8 and 3 is equal to 7. They have already given to us. So in that case, if a transversal intersect two lines, right now they are saying two lines. They didn't say these two lines are parallel. Just they are saying L is there, they intersecting two lines M and N. So in that case, if corresponding angles are equal, then the two lines, which lines? M and N, will be called what? Parallel lines. So we can say just it is a converse of the earlier axiom. So I hope it is clear to you. Let's move to next one. Now next one is saying what? Theorem 2. It is what? Theorem number 2. What it says that if a transversal intersect two parallel lines, if a transversal intersect two parallel lines, then each pair of alternate interior angles is equal. Let's see. As you can see here, pair of alternate interior angles, we have already learned alternate interior angles. As you can see here, 4 and 6, they are interior angles, okay, and they are alternate. Of course alternate because one is coming on the left side of transversal, another is coming on the right side of the transversal. In the same way we can say 3 and 5, this is also what? Pair of alternate interior angles. Now these angles will be equal. Why? Because we are doing a case in which M and N are parallel, which is cut by a transversal L. In that case, the pair of alternate interior angles will be equal. Okay, this is said by our theorem 2. Okay, now theorem 3, that is a, you can say, converse of theorem 2 only, says that if a transversal intersect two lines such that a pair of alternate interior angles is equal, then the two lines are parallel. So as I told you, it is a converse. Now what they are giving, they are saying that the line L is you can say that intersecting the two lines M and N. Now right now they are not saying these are parallel, just they are saying they are intersecting two lines M and N in which alternate interior angles are already equal. They have given that angle 4 is equal to angle 6 and angle 3 is equal to angle 5. They are already given. So in that case, this M will be parallel to N. Okay, you can say that we can imply this one due to the converse of the theorem. Okay, This is only they have given to us. Theorem 2 is also 1. Now students are thinking, sir, where is theorem 1 gone? So theorem 1 we have already learned in our previous video, in which we have talked about vertically opposite angles. Okay, now they are talking about theorem number, this one is already over. Now their pair of alternate exterior angles are also equal. We have talked in theorem, about the interior angles. Now they are saying those who are exterior angles, like 1 and 7. See, these both are what? Alternate, because one is coming on the left hand side, another is coming on the right hand side, but both are what? Exterior here. This is the pair of alternate exterior angles. In this same way, 2 and 8, these also what? Alternate exterior angles. So this will be also equal, in which case where M is parallel to N. It means that when two parallel lines are there which is cut by a transversal, then the pair of alternate exterior angles will be also equal. Okay, now theorem number 4, which says that if two transversal intersect two parallel lines, if a transversal intersect two parallel lines, then each pair of interior angles on the same side of transversal is supplementary. Supplementary means where the sum of two angles will be equals to how much? 180 degree. Let's see here, 4 and angle 5. See, L is the transversal intersecting the two lines M and N parallel lines. So in this case, the sum of these two consecutive interior angles, 4 and 5, the sum of angle 4 plus angle 5 will be equals to how much? 180. In the same way, 3 and 6, angle 3 and angle 6, angle 3 plus angle 6 will be equals to how much? 180. It is said by the theorem number 4. Okay, sum of consecutive interior angles on the same side of the transversal are supplementary. It means their sum will be equals to how much? 180 degree. In which case where M is parallel to N and cut by a transversal L. Okay, as you can see here, 4 angle 4 plus angle 5 180, angle 3 plus angle 6 180. You can use your, you can say what, compass protector also. Let's check here, they are showing 180 degree only. Okay, this part 180 only. Okay, if a transversal intersect two lines, okay, then such that a pair of interior angles on the same side of transversal is supplementary. As you can see here, if we are given these two lines M and N, and they didn't said that these are parallel, they have given this L is intersecting these two lines, and in this case angle 4 plus angle 5, as you can see here, given 180, and angle 3 plus angle 6 is given how much? 180. It is given. Therefore we can say that, we can conclude that here in this case M is parallel to N. Okay, it is a converged theorem. Clear? I hope it is clear to you. Now theorem number 6, last. Lines which are parallel to the same line. Lines which are parallel to the same line are parallel to each other. Let's see the diagram. As you can see here, these lines, L is parallel to M, L is parallel to M, and this N is also parallel to N, M is parallel to N. See, L is parallel to M and M is parallel to N. So what is common here? Common is which line? The common line is what? Line M. This is the common line. Okay, so lines which are parallel to the same line, this same line is what? Line M. This is the same line here. Okay, same line are parallel to each other. So which lines are parallel to this same line? This line L and this line N. These both lines are parallel to this line, this same line M. So in this case, these lines are also parallel to each other. So in this case, it means line L will be also parallel to line N. Okay, because L is also parallel to M and N is also parallel to M. So in this case, M is common, it will remove. So what left? L and N. So L is parallel to N. As you can see here, line L is parallel to N. Okay, this is theorem number 6. So we have done our all theorems. So I hope it is clear to you. All theorem and axioms we have done. I have explained each thing. So on the basis of these things, we can solve exercise 6.2 given in NCERT book and other questions also based on these theorems and axioms. I hope it is clear to you. So at last, I just want to say, be safe and God bless you all.